Hi, my name's Jeff Nepper, Managing Partner at Flow Software. Thank you for joining me as we discuss how you can turn historic and real-time data into calculated tags, KPIs, and events at enterprise scale. And that's really the key, isn't it? How to do this not once, not twice, but at full scale across your entire enterprise. So our goal is to help you take your analytics to the next level. Let's dive in. So let's start with a quick question. What data source is key for analytics? Is it real-time or current value? Is it historic records? Or is it manual data? Listen, they're all three important, but analytics are built on historic records. This is exactly how we've done our analytics for over 40 years. If you think about it, the analytics that we've been doing are descriptive and diagnostic. What happened and why did it happen? And we've been able to do this by looking at trends, having subject matter experts look at a couple different data points, maybe overlay some event records, and they've been able to tell us exactly what's been happening in their operation. But currently, we're seeing a change. We're seeing a move to a new type of analytics, predictive analytics. What is likely to happen in the future? So I've got a line, a piece of equipment on that line. By analyzing data, I've got a machine learning algorithm that tells me that that particular piece of equipment is 92% likely to fail inside of the next 48 hours. That's predictive analytics. That's happening in some cases in very small proof of concepts. It's not really being applied across the board by most manufacturers. And then there's the holy grail, the prescriptive analytics. It's taking the predictive, the forecast of what will happen or might happen, and it's applying a rule around our organization's goals. So according to my organization's values, what's the action that I should take to align with the outcome that's desired for my organization? So if we take our example from predictive, on our line we might have a filler, and the predictive model might say that we're 92% likely to fail over the next 3 days. Prescriptive would look at the product that we're making, the relationship with that vendor. It would look at the inventory of the parts on hand, the personnel who are available in order to change that part and do service on that filler. It would basically come back with an outcome or a suggested action based on the outcome that we would need. So it might say, the product that we're making right now is for one of our top 3 suppliers. We need to make sure that we hit this on time. We've missed 24% of our last deadlines. The part is not on hand, nor is the SME to do the actual swap out, and we have scheduled downtime in 7 days. We can have the part and the SME here, and if we reduce run rate by 14%, we will still make our goals for the product. The likelihood of failure will be reduced to only 34%, and we can change the part out at our scheduled downtime in 7 days. Okay, so that is a ton of data from a ton of data sources. And in order to be able to do those types of analytics, we have to be able to bring together data from more than a dozen different sources, cleanse it, normalize the formats, and actually find value within it. So when we think about that type of an example, we can't get there if we continue to do our analytics from a foundational level the way that we've done them for the last 40 years. Meaning, we can't take our Industry 3.0 approaches to an Industry 4.0 style of analytics. It's really just like putting lipstick on a pig and calling it something different, if you will. So then, if that's the problem, how do we find a way to stop doing it the way that we have been doing it? Well, first, we have to recognize how we've been doing it. So let's take a look at how we've actually siloed our analytics effort. And that is basically when we have a business use case, the very first thing that we look to do is we identify, based on an Industry 3.0 approach, we identify an application that we can land our work within. And this is usually based on a subject matter expert's choice. So if I have someone who's used to working in Power BI, they would pick Power BI. Someone who spends their time in, say, OSIsoft or now Aviva Pi or AWS, they tend to lean towards those tools. Even Excel, if somebody spends a lot of time in Excel, they'll tend to pick Excel. And so within that application of choice, we then build our custom integration work. And we do this step by step as we climb up the ladder, and it starts by connecting to all of the different data sources that are necessary, ingesting that data, standardizing the format, cleansing the data. We add a little bit of context, the minimal amount necessary, because that takes time. We perform our calculations and our aggregations, we validate the results, and we get value. That's the way we've been doing it for 40 years. And it's kind of costly, because to go from data to information is expensive. That integration work, bringing those sources together, is typically as much as 80% of our project cost. But we do get value. We get value from the output, but along the way, we are creating a stovepipe. So we are creating an isolated vertical system where all of that integration work is captured inside of an application. But, like I said, we do get some value. And so since we get value, we tend to rinse and repeat. And every time a new business use case comes about, we look for another application to do the work in. Sometimes we'll do multiple projects inside of one application, but over the course of time, we're spreading all of that work over a dozen or more applications inside of our enterprise. And the tough thing about this, creating these dangerous stovepipes, is that what we're not creating along the way is a single source of truth for both data access, one place to go to get all of our analytics, as well as we're not creating a single source of access for the integration work, meaning we're stranding previous integration work inside of these applications. We're also segmenting our subject matter experts. So we're not getting great collaboration because our subject matter experts keep looking to their applications instead of working together in a central location. Data governance is extremely hard to apply here because we have multiple business rules, multiple definitions living across multiple applications, and the big word of today, scalability. I can make this work for 1 and 2 and 3 off solutions. I can't make it work globally across 30, 40 or more sites. The reality is we will never scale analytics by continuing to create stovepipes and data silos inside of our own organizations. And every time we do more point-to-point integration, every time we ingest more data sources, do the integration work, and land that work in the application layer, we are creating more stovepipes. We are creating more isolation, more silos, and we are not adding to our ability to scale analytics. Let's take a quick look at a plant. We've seen this plant before. We've seen the wall where all the information lives inside of a plant. What do you see? I see a handful of different reports. I see a whiteboard that's got a lot of KPIs or indicators for my team. But what I really see is a lot of stovepipes. I see those vertical integrations inside of applications, all of that project work that was done years ago, lost. In fact, the men and women that probably did that work likely are no longer with the company, or perhaps the integrator that we contracted with is no longer in a relationship with us, and that work is lost. And it gets even more complicated when we try to extend this type of reporting or this type of analytics to our enterprise, because then all we do is try to connect our plant data ecosystem stovepipes and create new stovepipes inside of our enterprise data ecosystems. Sometimes we even try to bring things back down to site. It doesn't scale. So let's take a look at a way we could scale. The solution to this might be the way that we would build a library. This is Trinity College's library. They have spent centuries collecting all of the work across the UK. Everything copyrighted, everything published inside of the UK lives in this library. What they did not do is they did not create 10 separate libraries. They did not build separate teams and task them for 20 years to go about building their own libraries and then come together and see what they have. No, they centralized their efforts, they collaborated together, and they took one united approach on how they would collect all of the work across the entire enterprise, if you will, of the UK. Well, in our integration work, we are duplicating work over and over again, and we are missing work that we could be capturing and centralizing. So as we look at these stovepipes, we'll see that we're going through the same processes over and over. There's no reason for us to orphan that work and lose that work and relive that work. Instead, we should centralize that work. So if we take all of the different data producers and the data consumers and unite them with one common centralized library for integration work, we'll be able to scale our analytics. And that's exactly what Flow software offers. So the benefits of scale. Every project that we build benefits from previous projects, and the work that we do today continues to expand with the next project as well. We have really strong data and engineering governance. That means our business rules live in one place, we're not replicating them, and we can enforce them. We get highly contextualized and available information. That's because every time we are touching our data and adding context, it doesn't get lost in an application. Instead, it gets centralized. That gives my subject matter experts a place to collaborate, and ultimately, it frees me from having to create just a single historian as far as a standardization, or a single SCADA application as my standardization. It disconnects me from my analytics from historian, SCADA, or even my application layer on how I want to visualize that data. That means I can plug and play more applications into my organization, and I have more flexibility along the way. All right, so let's talk about how we would actually scale this issue and solve enterprise scalability. So first, I want to tell you a bit about Flow software. Flow exists to give teams decision-making superpowers. We are all about scalable analytics infrastructure. Flow is not just an analytics application. Flow is a path to better analytics foundations. Flow's goal is to help you build Industry 4.0 analytics frameworks. We absolutely love being in the middle of the OT and IT convergence, because to build strong analytics, that's exactly where you have to be. And Flow is a mature product. We've got 11 years of developing the product behind us, and we are on our 6th major release. So we've been blessed to work with some of the most data mature companies in the world, and we've learned a lot by working with them along the way, and we'd love to help you with that process and teach you what we've learned in our experience. All right, so let's take a look at how Flow works to unite your analytics using a framework. There are 9 components behind Flow that make this all possible. Let's take a look at them. We can group these components into 3 batches and talk about that based on the 3 steps that we take to help you scale your analytics. So the very first one is data and engineering governance. Flow uses a common information model that will allow you to apply strong governance for both the engineering work and how you treat your information inside of Flow. Then we have a series of tools that will help you to create highly contextualized information, as well as another series of tools and applications to help you share that information across your enterprise with both people and other applications. All right, let's dive in and take a look at data and engineering governance. Data and engineering governance. At its core, Flow relies on creating a common information model. This common information model is essentially breaking us free from the old way of doing things. So what did we used to do? We used to try to standardize our tag naming across an entire enterprise. Now, if you're only 1 or 2 sites, this is possible. But if you're more than 3, 4, 5, 6 sites, you're going to find that trying to create a standard tag naming model across SCADA and Historian, theoretically, it's a beautiful idea, but to execute it and keep it is very expensive and very costly. Growing organizations are constantly acquiring new assets. If you're acquiring new assets, it would be very expensive to change the way that those assets function from day one. The other old way of doing things was to limit the application variety. That means, hey, we're only going to use this brand of Historian, or we're only going to use this brand of SCADA. We would create long Excel tables of our tag naming standards, of the rules that we wanted to follow, the calcs, and the definitions. It's funny, just about 6 months ago, I was helping direct a MQTT Sparkplug Plugfest as part of Integrate Live. We had 6 vendors that were participating. I actually used Excel to create a long list of tags and help standardize tag naming for that exercise. With only 6 vendors participating and a very clearly defined set of rules inside of my Excel document, down to the exact tag naming structure, I would have thought that there would not have been a problem. But we had 3 different naming conventions show up the day we tried to do our Plugfest, and that wouldn't work. So imagine the confusion if we now are using 15 sites, 4 different sets of integrators. It just doesn't work. So with Flow, we're able to create corporate managed templates. These templates are going to help you define your process, your machines, and your equipments inside of that central library. And you're going to be able to create attributes, calcs, KPI, and event definitions that are then deployed from the corporately managed library to your actual data projects and sites. Let's take a look at what that would look like. So you would have a Flow instance living in enterprise, and this is where your template rules would live. Templates have the rules around how we cleanse data, how we handle exceptions with our data, all of our KPI definitions, our event definitions, and more. Then we deploy these definitions down to our site instances when we have a project that we are doing. So what do these profiles look like? Well, let's take a use case example. It's important to note that when you apply Flow as a solution to your analytics program or strategy, that you're not trying to define everything all at once. Instead, Flow is a way to grow your analytics project by project. So maybe your very first project is around creating some KPIs and reports around production totals for a few of your sites. We would go into Flow and we would define a line and give it that name in our profile. Then within the line, we would create a model, we would create a hierarchy. Maybe we have a filter, and a filter is associated with a filler and a tank is associated with a series of valves. Well, our line also has a series of fixed properties, things that don't change very often, if ever. So the area it's associated with, the equipment numbers, the line name, the operator, the manager, maybe the site. And what we're actually defining at this point is simply what is the data type and what is the format of that data. As we look at dynamic properties, we're going to also add engineering units to that definition. So we might have a dynamic property of our line of our inventory produced, and you can see here that's referred to as bottles. And then we can add to that and we can say, let's also map the amount of water that we're using in our production. Let's map the electricity, maybe some raw materials, and we'll capture a product code that we're making at the time. So that's our fixed and our dynamic properties. Dynamic properties, often you could associate these like process variables. Then we define the events that we want to monitor as part of our line. Now, our use case right now is production totals. So we might want to monitor when we change product. So it would be a start trigger definition when the product value changes, and an end trigger definition. Again, if the product value changes, stop the event. So we create a flag when the product changes and we record the duration of that event. We might also create some start and end triggers for downtime tracking. And then we define the attributes that we want to collect around the duration of the event. So if I was down, I'd like to know what the flow average was while I was down, and I'd like to know what product we were making while I was down. And perhaps I also have a rule around a machine fault. Okay, so now that we've got the events that we want to monitor, we've essentially created these event durations that we can use later on. And when we come into our measures, now we're going to actually define the KPIs that we are looking to capture as part of our production totals. Now, KPIs are typically some type of an aggregated number of a dynamic or fixed property across a period of time. And that period of time could be a time interval, like an hour, a day, a shift, or it could be a duration of time around an event. So let's look at one of the KPIs that we're going to build, and that is our total throughput. The actual total throughput is essentially looking at our filler. It's taking the good and the bad, adding them together, integer, it's bottles, and we're going to keep that for, say, 3 years. All of this gets defined in our corporate managed library. Great data governance when this is where it's being defined. Then I can create conditional rules. If the flow quality is not good, write null. If it's outside of band of 0 to 150, again, write null. Else, keep the value. Let's look at some other examples. I might want to get my total throughput day to day running. So that gives me from the start of my day until now. Start of day, we're going to talk about just in a little bit around how we contextualize that time. What is my percent change? So look at this equation, today minus yesterday. So at this point in time today, compared to this point in time yesterday, divided by yesterday times 100 gives me a percentage. That's my throughput change. And then product totals by hour. Let's look at this. Let's take every hour and we'll take our total production and we'll slice it. All right, so I've got my measures, I've got my events. I've essentially created this model of my process around production totals. Now, inside of Flow, as I've built those templates, it's going to look exactly like this. These are all of the different KPIs that have been built out actually in one of our demos that you can download from flow-software.com. This gives you a great example of how to use Flow for this type of use case for production totals. What's important to remember is that over time, these models will expand because the next time I come in for my next data analytics project, I've inherited all of this work. I can further expand the definitions as I need for my equipment, for my process, for my machines, or for my sites. So by continuing to expand the definitions, all of my previous projects can take advantage of those new rules or those new KPIs, events, and properties. All right, so the old way of trying to govern or evolve non-centralized business rules and integration work, it just doesn't make sense. We know that. We need to take this approach and centralize that work in one place that we can easily manage it and expand it. How about point number 2, step number 2? How do we move from data to highly contextualized information without having to do all of this point-to-point integration work and losing that work inside of the application layer? 3 different tools inside of Flow will help you do this: data source connectors, calendar management, and our calculation engine. So the old way would have been having multiple sources of data, each lacking context of each other. We would try to inject that context typically at the enterprise level where we're building our models and doing our analytics, far separated from the subject matter experts of the operations side who have that knowledge to share the context. And we would have long periods of data wrangling as a result. So our data scientists, our data analysts would be spending 60, 70, 80% of their time trying to add context to the data that has arrived inside of the data lake to them. That's why these models take months, if not sometimes years, in order to build, often with poor results. So Flow's goal is to add context early, to have our OT folks putting context into this data story as part of their daily job. Remember, the key to analytics, it's the historic data. It's the manual data plus the real time added on top of the historic that really adds the value for analytics. Analytics is not about simply having real time data pass through. That concept is short of what is necessary for analytics. We want to avoid having to do all of the point-to-point connectivity from historical databases to analytic applications over and over again. Therefore, we have to focus on how we connect historic data into this hub of analytics. All right, additionally with Flow, I'm also going to be able to have my enterprise teams that have been working with data, not just work with raw, uncontextualized data, but they're going to be working with data that's ready to go for them. And that helps me make site-to-site comparisons simple without losing the uniqueness that exists at sites. And it's because of the data source connectors, the calendar management, and the calc engine that I can do this. So for data source connectors, we can connect to every flavor of historian you can imagine, from SQL to NoSQL, from specialty historians like Aviva Pi or Canary, to all of the different databases that exist inside of your organization. And we've got a series of standard protocols that we use on our connectors in order to do that. Of course, beyond historian is also all of the relational or transactional data sources. So every variety of SQL, Flow has to be able to connect to as well. We pick up the real-time data by having, again, more protocol ability within OPC servers, MQTT brokers, Kafka streams, Telegraph, and of course the standard web APIs. And then also a way to connect and provide web forms for manual data collection. So these web-based forms are great for categorizing downtime, entering production goals, capturing measurements on the equipment that's currently doesn't have instrumentation, feeding over to a historian, and even correcting values that might have been bad and versioning that inside of Flow. All right, so we have to talk about calendar management. I hinted before in the profile when we were talking about time with KPIs that we have to be able to define time. And every site runs a little bit different, right? So some sites might start their production day on a Monday at 6 a.m. Others might start their production day on Sunday at midnight. Flow gives you the ability for each of your deployments to create custom calendars that define shift patterns, financial years, production years, and handle all of the weird one-offs that we know to be true inside of the OT spaces. Then, once we've connected our sources to the information model that has been pushed down from the corporate location, we've built in our time periods, then the Flow calculation engine takes all of those rules that are associated with that template, all of the conditions that get defined at the corporate side, and allows you to run all of these calculations without any type of issue. So this is where the scalability really comes into play. We've been able to deploy faster, and now we can execute without having that normal lag that you see in your current solutions. So the specialties of the calculation engine behind Flow are to take multiple data sources, SQL, historian, real-time, manual data, and bring that together. That means that we have to be able to standardize multiple data formats, normalize time and align timestamps that typically don't ever align, cleanse that data according to the rules that have been set up, perform those calculations, and then slice by the correct time or event period. Let's take a look at what that looks like. So we're going to use two databases as our example. We'll use a SQL database and we'll use a historian database. And so when Flow is connected to either of these systems, essentially, well, let's take a look at it this way. So we've created our throughput model, and we are connected to a SQL database that has the product that we've been making. We're connecting to a historian database that has the totalizer that we need in order to run our KPIs. So when Flow connects to the SQL database, it takes that data. When it connects to the historian database, it reads that data as well. And it gives me the ability to create a new tag with all of the different values and assign point normalization to that new calculated tag. So I get zero data loss, I get row-based calculations, and it's a great way to cleanse my data, to filter my data based on state or condition, and then be able to use that data inside of Flow. So if I want to aggregate that data and create new measurements with Flow, I'm going to read all of the data that's been cleansed. I'm going to perform the correct aggregate, and then I'm going to roll that number up to a time period. So this is a great example of an hourly or shiftly or daily production. Now, if I want to do more than just this around time period, that's where I bring in the concept of events into Flow. And so with events, we connect to another tag that establishes our start and stop triggers of an event. We are able to then take those event periods and overlay them across our contextualized calculation and create yet another measure. So in this simple example, I could have a total production by shift. I could also have a total production by product, as well as a total production by product by shift. And with Flow, I could create as many different time slices of this as I would want. So I could have down to 1 minute aggregates, the whole way up to monthly or yearly aggregates. And I could apply multiple event frames or context of multiple events across this data. So I'm using this calculation engine, following the rules that have been established in my common information model profiles. And I am cleansing data. I'm handling my conditional rules. I'm creating new tags on the fly, these calculated tags. I'm then aggregating these tags into higher level KPIs. I'm defining my events, and I'm contextualizing based on those event periods. All of this is happening automatically for me. All I'm doing on the site is connecting the right pieces of equipment to my model and establishing the context around time, and then any specific context that I need at my site. Maybe for instance, my band, for some of my rules, my band may not be 0 to 150, so I would adjust that for what's appropriate for my site instance. Okay, so with my calculation engine, I can also handle those late data rules. Store and forward events within my historian, data that arrives 3 hours after I've already run a calculation. These are the things that break most applications inside of our space. But Flow, because again, mature product, 6 versions, 11 years ago, it started out of the OT world. We understand that not all the data arrives when you want it to. That's why Flow is able to be state aware of the historians it's connected to. It's state aware when underlying SQL databases have inserts or new values added, and Flow is able to rerun all of the calculations that it's previously run and version any of those calcs that have new outputs. All right, so again, how would we have ever shared context using this architecture? We just can't. We continue to make these silos of information, and we can't have this cross-pollination of context. It's so important that we take the context that is necessary for our data scientists and analysts, and we get that in early. Only way to do that is to centralize our analytics efforts. All right, final area. How do we share information openly across our organization, making sure that only those that are supposed to have access do, and share it not just with people, but also with the right applications? We've got a series of tools, 5 in total, that Flow offers out of the box to help us do this. So we used to replicate entire databases. This is that data lake concept. Take all of the data in my historians, replicate it to level 5 into the cloud, and that's where we're going to do all of our work. We used to bounce between multiple applications, multiple services, multiple dashboards, trying to find a way to look at all of these different data sources. And we used to have to license and then learn that technology and connect to a myriad of databases in order to try to centralize this information. With Flow, we suggest you do this a different way. You take the data that's already in your validated databases, your historian, your SQL databases, leave it there. Instead, we want to connect our data consumers easily to those data sources and create a a bit of a fluid pipeline to get that data where it needs to go. We want to create trustworthy information that arrives where and when you need it. And we want to also create, of course, a single source of truth for all of your data queries and your data syncs. Let's take a look at how we do that. So it starts with our KPI and event database. We're going to store the outputs from the calculation engine for the measures and events. These get stored in a SQL database. It's nice and convenient. There's no reason to replicate all of the history that's already in the historian. Instead, we do all the processing of that historian as needed based on the time periods of our KPIs. And then we store the outputs of those inside of our KPI and event database. Our notification engine then can share that information. And it's important that we share that information not into yet another application, but inside of the sources or the applications that your team is already using. So if Slack is your preferred method of communication, Flow publishes KPIs and events into Slack. Or if you prefer email or text or Microsoft Teams, Flow publishes there as well. And a great way to share information with people is with dashboarding. The Flow dashboards are not just another dashboard. In fact, Flow dashboards are designed to help you see not just real-time data or raw data, but mainly focused on KPIs and reports, data tables, downtime, event tracking, and of course providing data forms and data coding for that manual contextualization. Flow makes it easy to share this information as both PDFs or images. It's important to note that it nails the data tables. So how many times have you tried to print a report that's got a data table that has some type of a sidebar, and when you print it, you don't get the entire data table? Flow makes sure that that's possible. It also helps you to export in CSV format the data that's on the page, or even create comment strings inside of your dashboards. And most importantly, inside of a Flow dashboard is the capability to interrogate that data. What do I mean when I say interrogate that data? That means if you see something on a Flow dashboard and you question it, you have the ability to drill down into it and really take a deep dive. Let's look at an example of this. Remember before, our use case here was throughput calculations. Here's a Flow dashboard that is perfectly aligned with that use case. We have two main visualizations at the middle and bottom of the page. We have our accumulated hourly production starting at midnight, which is the definition of our day at this factory, and we're currently in hour 21. We can see on this middle visualization what we've produced, what we're projected to finish at, and a comparison to our best day ever. Best day ever, 797,000 bottles. Currently, we're projected to finish at 693,000 bottles. At the bottom is an hourly time slice of this data that clearly shows me the hours that we were producing above our goal and the hours in red where we were producing below our goal. Let's look at the KPIs across the top. Throughput percentage is jumping out at me. It's negative. The color has changed. I'm at a negative 18.19%. Now, we all know that if we can't trust the information, we're less likely to act upon it. So Flow wants to solve this problem by giving me, as say an operations manager, the ability to drill into any number on this page. So if I look at a negative 18% and think, that doesn't seem right, I can click on that on my dashboard, and immediately Flow will expand from the bottom and show me the definition behind this KPI. Let's take a closer look. So total throughput, actual percent change, is linked to filler 1 good bottle counter. Now that linkage is defined inside of my common information model. So the profile that we build around this filler is where that rule lives. Flow is able to show me that rule, not just the rule, but also the calculation. Let's take a look at it. It's today minus yesterday divided by yesterday times 100. So my two variables are today, which is my from midnight until now, compared to those same time period from yesterday. And down below, I see the two variables expressed as those actual numbers. So I could check the math right here, right now, using my calculator. Hey, everything looks good there, no issue. But I want to dive deeper into that 604,000 number for today. Where did that number come from? I click on it and it dives in and it shows me the KPI that is built on. That's the daily sum of actual throughput. And I see every hour the individual slice of that data. So hour 1, 35,379 bottles. If I'd like to take a deeper look at that number, all I have to do is give it a click. And now I get to see the final KPI in my system. Again, we defined this back in our profile. That was good plus bad. Good, 35,000 bottles inside of that hour. Bad, 212 bottles. Now, if I click on this, technically I don't have that information inside of Flow. That information is living as part of my totalizer tag inside of my historian. But when I click on it, Flow makes a query to the historian, asks for the raw data, and then displays it for me. It doesn't just display it, it also shows me how it brought that information in from the historian using the counter aggregation, looking for that hour, till it shows me the tag path inside of the historian and gives me the historian name. Now, I feel confident that this information is accurate, and I can come back and actually leave a comment inside my dashboard saying, hey, I'm no longer worried about the number. I've drilled down. KPIs and underlying historical source are solid. That's what it means to be able to interrogate your data. All from one dashboard, connected to multiple sources. I don't have to understand the underlying historian. If Flow knows about it, I know about it. That's the key. All right, so that the same capability that we can use to drill down in our dashboards is because of our API. Everything inside of Flow is built upon our API, and we publicly expose this REST API and make it open, not licensed. That way, you and all of your team can request data from Flow, not just KPIs and events, but calculated tags, raw data from the underlying sources that are linked to your profiles, your common information model, and of course, the definitions around that common information model itself. So do I have a model for a pump? I do. What are those dynamic and fixed properties? What are the events? What are the measures? What are the conditions on how I cleanse that data? All of it's available inside of that API. APIs are great for pulling data on demand. What about publishing data on trigger or on schedule? That's where the Flow data sync comes in, so that I can take the information inside of Flow and I can insert it into other SQL databases. I can publish it to Kafka streams, to MQTT brokers. I can batch data and drop it into a data lake or into cloud tools or other machine learning and AI tools. Imagine the value of having good, clean, processed data show up in your machine learning tools. Imagine the joy of your data teams to get this data ready for them to use instead of them spending so much time trying to contextualize and work the data. And anything inside of Flow is available to you. That means the profiles and the definitions, the raw data from any tag connected to those profiles gets passed. The calculated tags that you use as filters and as cleansing tools gets passed. And of course, our events and our measures also get passed. So on an enterprise scale, that means if I deploy Flow at all of my sites, the sites are handling the individual context, they're defining their patterns of time, they're naming their shifts, their shift patterns, they're indicating their individual operational differences, meaning things like inside, outside of band, how they cleanse data, appropriate for their operations. And all of that information is available to my teams by connecting to a tiered Flow instance. So that API and those data syncs don't only work for the sites where Flow's deployed, they also work for the entire enterprise, so that anything connected to your enterprise library of Flow, I can pull down from the site up through that into my entire enterprise ecosystem. So remember, I don't need any knowledge of the underlying site data sources in order to pull the raw data from them. All I need to know is If it's linked to Flow's models, then I have access to it. Okay, so I hope that through this talk, you're seeing the fact that there's no way to scale analytics, to simplify analytics, and provide data access for everyone in my organization if I continue to do my integration work at the application layer. If that's what you're seeing, then it's time to consider centralizing your integration work and scaling your analytics for success today and tomorrow. So remember the benefits. Every project that I do, if I follow this new architecture, will benefit from future projects. I get to enforce strong data and engineering governance. I get highly contextualized information from the beginning, available to everyone. My subject matter experts are collaborating, and I am able to break free from reliance on single vendor solutions for historian, SCADA, and my analytics applications. If I want to use Power BI, I use Power BI. I just connect it to Flow. If I want to use Canary and Aviva Pi across my organizations, I use Canary and Aviva Pi across my organizations. Flow connects to either historian or any historian, and my enterprise teams, my site teams don't have to have strong underlying knowledge of that database. All right, so how do we move from where we are now to this new strategy? Well, we do it by adding value quickly and equally to both the enterprise and the site. What does that look like? Well, at site, I take my plant managers and my process engineers, and I help them get one location for all of their KPIs. So the reports that they've been living with for maybe a decade that are half broke and have a ton of different moving pieces that no one really understands, all of that data comes into one system. My teams can go to one place for that information, they can interrogate it, and I simplify the way that they add data and code data manually. On the enterprise side, my executive team loves this decision because they can now easily govern their business rules, their engineering work, and their information. So this centralized templatized deployment of these equipment and process profiles makes everything that much easier. And of course, the data scientists and the analysts love this solution because now they've got a single source of truth of contextualized, rich information. We know that great teamwork is what drives progress. We'd love to partner with you on this journey. So suggested next steps. Ask yourself, is this message resonating with me? If it is, who else needs to see this inside of your organization? You're welcome to share, of course, this presentation or schedule a time for us to do this presentation for a live audience. Easiest way to do that is to reach out at info@flowsoftware.com. info@flow-software.com. Then once the right people have seen this and you have your buy-in, it's time to do a demonstration of Flow. We'd love to show you exactly how we use the tool in order to build out the report that you saw on that dashboard in that project. And then finally, a technical deep dive. Sometimes this is a proof of concept. Sometimes it's a series of sessions where everybody gets to ask all of their questions. No matter what that looks like, we know that there's a lot of considerations you have to make, and we really want to help you in that. So if any part of this has resonated with you, I encourage you to share it amongst your peers and to reach out to us anytime at flow-software.com. Again, I thank you for your time. My name's Jeff Nepper with Flow Software, and we're really excited to help guide you in your journey for scalable data analytics.